For 15 consecutive years, False Bay, South Africa, behaved exactly the way marine biologists expected it to. Great white sharks returned season after season. Researchers came from every continent to study them. They breached completely out of the water to hunt seals, making False Bay the greatest great white shark hunting ground on Earth and one of the most important shark research sites ever established. Then everything changed. In 2017, marine biologist Dr. Alison Koch received photographs of a dead great white shark lying on the seafloor. Its chest had been opened with such extraordinary precision that her first thought was that someone had cut it open with a knife underwater. Nobody had. Two orcas had done it. They became known as Port and Starboard, named for their collapsed dorsal fins. In the wild, fewer than 1% of orcas develop collapsed dorsal fins, a condition almost always associated with severe illness or dying animals. Port and Starboard were neither. They became the most prolific shark hunters ever documented. Nobody knows where they came from. The earliest confirmed record of the pair places them near the Namibian coast in 2009, but their birth pod, their origin, and where they learned the hunting technique that transformed an entire coastline remain unknown. They locate a great white shark, ram it, flip it upside down, and hold it there until the animal enters a state of complete neurological paralysis. Then they open the chest wall near the pectoral girdle, remove a liver that can weigh as much as 500 pounds, and leave almost everything else behind. They do it in under 2 minutes. Great white sharks had ruled the top of the ocean food chain for roughly 11 million years. They had no documented natural predators. When Port and Starboard arrived in False Bay, the sharks did not fight. They fled. By 2018, the world's most reliable great white aggregation site held no great white sharks at all, and the chain of ecological consequences that followed forced marine biologists to rethink how stable an ocean ecosystem really is. If you're tucked in right now, phone dimmed, trying to let your brain slow down, this one was made for you. Give it a like, subscribe if you haven't. It's free, and it helps our channel more than you can imagine. Now, let's return to the day everything changed. Recognition came before understanding. Along the waters near Gansby, observers began noticing the same pair of tall black fins appearing again and again, each marked by an unusual bend that made identification possible even from a considerable distance. One fin leaned toward the left, the other toward the right. In the language of ships, those directions became names. Port carried the fin folding left, Starboard carried the fin folding right. What first appeared to be little more than a convenient field marker would eventually become one of the most recognizable signatures in marine biology. The pair were formally identified during 2015 by whale-watching operator David Hurwitz, whose repeated encounters revealed that these were not passing visitors, but familiar individuals returning to the same coastline. His names were quickly adopted by researchers, allowing observations from different teams to be connected into a single record. Every confirmed sighting added another point to a growing history, transforming anonymous dorsal fins into two known animals whose movements could be followed across years instead of isolated afternoons. Their appearance carried another detail that attracted scientific attention. The teeth of both males display a flatter profile than that seen in many other documented orca populations, a characteristic associated with a South African coastal ecotype. Yet this clue solved very little. No genetic sample from either animal has ever been matched to any recognized family group in the region. Every attempt to place them within the known network of related pods has reached the same destination, an empty space where ancestry should have been waiting. That absence is remarkable because adult male orcas almost never exist outside the structure of a pod. Across every intensively studied population, sons remain with their mothers for life, surrounded by siblings, aunts, grandmothers, and younger relatives. Hunting strategies, vocal traditions, seasonal travel, and social identity all emerge from those enduring family bonds. A healthy, mature male, spending years without a documented maternal group, stands apart from everything researchers normally expect to find in the wild. Port and Starboard have instead traveled together, and only together, through an immense stretch of coastline extending from Namibia to Port Elizabeth. Their documented range covers well over 1,000 miles of ocean, yet repeated surveys have never confirmed them moving consistently beside another established family. Sightings separated by months and even years continue to return the same pattern. Two males traveling as an enduring partnership across waters shared by many other cetaceans. The prey they chose deepened the mystery. Regional orcas had long been associated with dolphins, seals, and other familiar marine mammals. Great white sharks belong to an entirely different category. They are among the most refined hunters in the sea, equipped with senses capable of detecting the faint electrical field produced by a living heartbeat from several feet away. For roughly 11 million years, no natural predator had been documented regularly hunting healthy adult great whites. The decision by these two males to specialize in such prey arrived without any known local precedent. Looking backward through archived photographs extended their history only slightly. Researchers later recognized images captured near the Namibian coast during 2009 that almost certainly showed the same pair. Before that point, the record disappears. No verified photograph, confirmed acoustic recording, or reliable observation has yet carried their story farther into the past. Their exact age remains uncertain. Some researchers suspect they are older males, pointing to the collapsed fins and unusual hunting specialization as possible hints gathered across long lives. Others urge caution, noting that no birth record or long-term life history exists to support certainty. What remains is a remarkably consistent portrait: two adult males without a known family, unmatched in the genetic record, emerging from an undocumented beginning while displaying behavior that had never before been recorded along the South African coast. Patterns reveal themselves long before intentions do. When marine biologists compared carcasses recovered across successive years, they noticed that every wound occupied nearly the same place. Every missing organ was identical, and every abandoned body carried remarkably little additional damage. The repetition did not resemble the disorder usually associated with a struggle. It resembled a sequence, followed with such consistency that many researchers gradually settled on a different word. They called it a procedure. Everything begins with perception rather than force. Orcas navigate through a biological sonar system known as echolocation, producing focused sound pulses that spread through seawater before returning as echoes from everything they encounter. Those returning signals allow the brain to assemble an extraordinarily detailed three-dimensional representation of another animal, revealing its position, orientation, movement, and approximate size, even when visibility is poor. Before physical contact ever occurs, Port and Starboard already possess an accurate map of the shark moving beneath them. Once the target has been selected, one of the males closes the distance from an angle instead of approaching head-on. The collision that follows is powerful, yet its purpose is remarkably controlled. Rather than attempting to inflict catastrophic injury, the strike appears intended to interrupt balance and orientation. A shark left stunned for only a brief interval becomes far easier to manage than one responding with full strength and unpredictable movement. Precision, not overwhelming violence, defines this stage of the encounter. With the shark temporarily disoriented, both orcas begin guiding its body through the surrounding water. Their movements are coordinated with remarkable timing, each adjustment bringing the shark closer to a single position. Gradually, the powerful predator rotates until its back faces downward and its pale underside faces the surface. This moment forms the turning point of the entire sequence because everything that follows depends upon maintaining that inverted posture without interruption. The shark's nervous system then responds in a way that appears almost impossible for such a formidable hunter. Voluntary movement fades away, muscles cease resisting, the body no longer attempts to recover its natural orientation. Suspended in the water, the animal becomes temporarily incapable of swimming or defending itself. Port and starboard do not need to overpower continuous resistance because the neurological response has already transformed the encounter into something fundamentally different from an ordinary chase. Only after the shark has become motionless do the orcas begin the final stage. Their attention shifts toward the region where the pectoral fins connect to the body, an area known as the pectoral girdle. Working with remarkable accuracy, they create an opening that provides direct access to the liver positioned immediately behind this structural junction. The extraction is focused and restrained. Little else is disturbed inside the body cavity. When the liver has been removed, the remaining carcass is abandoned, carrying unmistakable evidence of careful selection rather than indiscriminate feeding. The efficiency of this sequence has become one of its defining characteristics. During a documented solitary hunt by Starboard in June of 2023, researchers estimated that the interval from initial contact to completed liver extraction lasted less than 2 minutes. For an interaction involving one of the ocean's most capable predators, the duration is remarkably brief, leaving almost no opportunity for prolonged resistance once the critical stages have begun. Dr. Ingrid Visser, whose work has examined orca behavior across many years, described the method as demonstrating surgical precision. That description reflects more than the appearance of the wounds. It recognizes a combination of anatomical awareness, coordinated movement, and practiced timing that suggests knowledge refined through repeated experience. Each successful hunt preserves the same orderly sequence, as though every movement has already found its proper place before the encounter even begins. Long before these two orcas entered the scientific record, the weakness they would one day exploit had already existed inside the bodies of sharks. It was not hidden within muscle, teeth, or bone. It lay within the nervous system itself, waiting for a very particular sequence of movement to awaken it. Evolution had carried this reflex across immense spans of time, preserving it through countless generations without ever placing it in the path of a predator capable of turning it into a dependable hunting strategy. Biologists know this condition as tonic immobility, a neurological response documented across an extraordinary variety of living creatures, including insects, birds, reptiles, amphibians, mammals, and fish. Although the outward appearance differs from species to species, the underlying pattern remains remarkably consistent. A specific trigger causes voluntary movement to cease, leaving the animal suspended in an involuntary state that cannot simply be overcome through effort or instinct. It is neither sleep nor unconsciousness. The brain remains active while the body becomes temporarily unavailable to it. For sharks, the trigger is inversion. When the body is rotated until the belly faces upward, the vestibular system inside the head begins receiving signals that conflict with its normal sense of orientation. Instead of producing a coordinated escape response, the nervous system enters a protective neurological state that interrupts voluntary control. The shark no longer reacts as a powerful predator accustomed to commanding its surroundings. It becomes an animal temporarily disconnected from its own movement. During this interval, the transformation is striking. Swimming stops completely. The jaws no longer attempt to bite. The body fails to roll itself back into its natural position. Even the breathing rhythm slows to a minimal resting pattern, conserving energy while the nervous system remains locked within the reflex. The dorsal fins straighten, removing the tension created by active swimming, and the entire animal drifts in the water without meaningful resistance. Left undisturbed, this condition commonly persists for around 15 minutes before normal control gradually returns. Marine researchers understood this phenomenon decades before anyone had heard the names Port and Starboard. Field scientists studying sharks frequently relied upon tonic immobility as a practical research technique. By carefully inverting a captured shark, they could examine its anatomy, attach identification tags, collect biological samples, and release it again without using chemical sedation. The method became well established throughout marine science because it provided a reliable and comparatively safe way to work alongside powerful animals that otherwise would have been extremely difficult to handle. One observation from the late 1990s hinted that another predator might also recognize this vulnerability. During 1997, near the Farallon Islands, off the coast of California, researchers witnessed a female orca holding a great white shark upside down at the surface for roughly 15 minutes. Unable to resume normal swimming, the shark eventually died. The event became the first documented eyewitness account of any non-human animal deliberately killing a great white shark in the wild. At the time, it appeared to represent an extraordinary curiosity rather than the beginning of a broader pattern. Years later, Port and Starboard transformed that isolated observation into something fundamentally different. Instead of relying upon prolonged restraint, they refined the sequence into coordinated teamwork. One animal disrupted the shark's balance and guided the inversion. The other maintained control while the neurological reflex unfolded exactly as expected. Every movement fit into a practiced progression that reduced a process once measured in many minutes into one completed in less than 2. The remarkable aspect of this story is not that the vulnerability existed, it had always existed. Great white sharks carried this neurological reflex through roughly 11 million years of evolutionary history while remaining among the ocean's most accomplished predators. What changed was not the shark. What changed was that two orcas discovered how to organize knowledge, timing, anatomy, and cooperation around a weakness that had remained untouched for ages, turning an ancient reflex into the foundation of an entirely new hunting tradition. The answer lies inside the organ that disappears. When researchers recovered great white shark carcasses, the missing liver was never an arbitrary detail left behind by an unusual predator. It was the central objective from the beginning. Everything that happened before the incision, from locating the shark to controlling its movement, existed to reach a single structure hidden deep within the body, one carrying an extraordinary concentration of energy, unlike almost any other tissue in the ocean. The liver of a great white shark is immense. In a fully grown adult, it can occupy nearly 1/3 of the animal's entire body cavity, weighing anywhere from roughly 300 to 500 pounds, depending upon the shark's size and condition. Rather than serving only as an organ of metabolism, it functions as an enormous biological reservoir, storing chemical energy accumulated over years of successful hunting. Few predators carry such a valuable concentration of nutrition within a single accessible location. Much of that value comes from a substance called squalene, a naturally occurring hydrocarbon oil present in exceptionally high concentrations inside the liver. Squalene contains remarkable amounts of stored energy, making it an ideal reserve for an animal that may travel immense distances without frequent opportunities to feed. Every successful hunt adds to this reserve, gradually filling the liver with fuel, capable of sustaining the shark across seasons of movement through open water. The same oil performs another equally important task. Unlike many bony fish, great white sharks possess no swim bladder to regulate buoyancy. Instead, the oil-rich liver provides natural lift, reducing the amount of muscular effort required to remain suspended within the water column. Without this internal support, the shark would expend far more energy simply maintaining depth. The liver therefore acts both as an energy bank and as part of the physical system that allows efficient movement through the sea. Satellite tracking has revealed the scale of journeys supported by these reserves. Individual great white sharks have crossed the entire Pacific Ocean, covering thousands of miles between feeding grounds with remarkable consistency. During these migrations, the energy stored inside the liver becomes the foundation upon which survival depends. Every mile traveled gradually draws upon those reserves until fresh prey replenishes them once again. In a very direct biological sense, the liver makes these long oceanic passages possible. From the perspective of Port and Starboard, this organ represents an extraordinary return for the effort invested in capturing such formidable prey. A single successful extraction provides a dense package of calories that would require many separate hunts to equal if they pursued faster marine mammals or schools of fish. Energy gained compared with energy spent strongly favors this strategy. The procedure appears remarkably efficient because it targets the richest reward while ignoring tissues that offer comparatively little benefit. The restraint shown after the extraction is almost as informative as the extraction itself. A great white, measuring around 15 feet and weighing approximately 5,000 pounds, remains floating at the surface with nearly the entire body untouched. Flesh, muscle, and many other nutrient-rich organs remain available, yet they are left behind. Such selectivity points toward intention rather than indiscriminate feeding. The hunt concludes the moment the desired organ has been removed, suggesting that the objective was defined before the encounter even began. Observations from other parts of the world provide another layer of meaning. In the Gulf of California, researchers have documented shark hunting orcas sharing extracted livers among adults and calves within the same social group. The meal becomes more than nourishment. Young animals experience both the exceptional reward and the behavior that produced it during the same gathering. Food and learning become closely linked, allowing practical knowledge to move naturally between generations through shared experience rather than instinct alone. Evidence accumulated one shoreline at a time. Each discovery began with a drifting body carried ashore by tide and current, examined by researchers who gradually realized they were no longer documenting unrelated deaths. Every recovered shark added another page to an emerging record. The details remained remarkably consistent, even as seasons changed and years passed, allowing individual events to merge into a continuous history shaped by the same unmistakable pattern. The first confirmed great white shark, attributed to Port and Starboard, arrived on February 8, 2017. It was an adult female, measuring roughly 8½ feet in length. Dr. Allison Towner examined the carcass with particular care, searching for signs that human activity might explain the death. There were no fishing hooks, no net injuries, and no wounds associated with boats or deliberate harvest. Instead, the opening lay at the pectoral girdle, and the liver had been removed with the familiar precision that would soon become recognized across many later discoveries. Only a few months passed before additional evidence appeared. During May of 2017, 3 more great white shark carcasses washed onto beaches along the Western Cape. Another followed during June. By the end of that year, researchers had documented at least 7 confirmed victims connected through the same distinctive injury pattern. What initially seemed extraordinary gradually became recognizable as a recurring feature of the regional ecosystem rather than an isolated biological curiosity. Those sharks varied considerably. Some measured around 11 feet and 8 inches, while others reached approximately 16 feet in length. Both males and females appeared among the documented carcasses. The diversity suggested that Port and Starboard were not selecting prey according to sex or body size. Opportunity appeared to guide the encounter more than any visible preference, provided the target belonged to the category of sharks carrying the remarkable organ they consistently sought. Among the animals recovered during that period was an especially familiar individual. Researchers had named her Khaleesi after years of repeated observations within the local population. Measuring close to 16 feet long, she represented one of the best-known great white sharks along that stretch of coastline, her movements contributing valuable information to ongoing scientific studies. When her body was eventually found, it displayed the same carefully placed opening and the same missing liver seen in every comparable case. Even a shark known through years of observation had become part of the expanding pattern. Not every encounter ended successfully for the orcas. Also during 2017, researchers documented a female great white shark that survived an apparent attack. She carried parallel toothrake marks across one pectoral fin, together with deep slash wounds along her flank, injuries consistent with an attempt to seize and manipulate her from above. Because she escaped, the observation revealed something important. The procedure depended upon precise coordination, and when the sequence failed to unfold correctly, the intended outcome could also fail. By August of 2019, the pace appeared to increase. Within a single period of observations, 5 great white shark carcasses were recovered, bearing the now familiar signature of liver extraction. The geographical reach of the incidents broadened as well, suggesting that the hunting activity extended across an increasingly wide portion of the South African coastline rather than remaining confined to one local feeding ground. Another striking chapter arrived during February of 2023. This time, the victims were broadnose 7-gill sharks instead of great whites. 17 carcasses were documented in a single day, each displaying the same opening near the pectoral girdle and the same selective removal of the liver. The repetition across another shark species demonstrated that the method was not limited to one particular anatomy. The objective remained unchanged even as the prey differed. Only a few months later, during June of 2023, Starboard was observed hunting alone near Seal Island in Mossel Bay. Without Port beside him, he completed the familiar sequence against a juvenile great white shark in less than 2 minutes. Published as the first scientifically confirmed solo orca kill of a great white shark in recorded history, the observation showed that the knowledge guiding these encounters could exist within a single individual as completely as it had within the remarkable partnership that first brought the technique to light. The movements of large predators often seem unpredictable until they are viewed from above, where scattered paths become patterns written across entire coastlines. Years of patient fieldwork had given researchers precisely that perspective. Dr. Alison Towner and her colleagues had fitted great white sharks with satellite tracking devices as part of a long-term monitoring program, allowing individual animals to be followed as they traveled through familiar feeding grounds. Each transmission added another point to an expanding map of lives unfolding beneath the surface. When Port and Starboard were confirmed in the waters near Gansby and a freshly killed great white shark was documented, the research team turned to those tracking records. Instead of examining a single shark, they compared the movements of every tagged individual present within the region. The resulting picture revealed something far larger than the loss of one predator. It showed an entire population changing direction almost at once. 14 satellite-tagged great white sharks departed the area during the same compressed period. This was not a gradual migration unfolding across many days, nor was it a series of unrelated departures by isolated animals. Individuals occupying different locations within the monitored coastline all began leaving within a remarkably similar window of time. The synchronized movement suggested that each shark had responded to the same environmental cue, despite being separated across considerable distances. Some of those sharks had established remarkably dependable seasonal routines. For years, they had returned to False Bay with enough consistency that researchers recognized them as familiar visitors rather than occasional wanderers. Their histories were preserved through repeated observations and tracking records extending across multiple seasons. Following the appearance of Port and Starboard, those dependable cycles were interrupted. Several tagged sharks remained absent for weeks, while others did not return for many months, leaving feeding grounds that had previously formed a regular part of their annual movements. At first glance, such departures might appear to result from the direct presence of hunting orcas. The evidence, however, pointed toward a more subtle mechanism. Not every fleeing shark had encountered Port or Starboard face to face. In several documented cases, the orcas were no longer nearby when the sharks altered course. Whatever warning reached them had lingered after the hunters themselves had already continued along the coastline. Researchers believe that warning exists within the water itself. During liver extraction, oils released from the damaged organ disperse through the surrounding sea, carrying a distinctive chemical signature. Great white sharks possess one of the most refined senses of smell in the animal kingdom, capable of detecting extraordinarily faint traces dissolved within immense volumes of seawater. The lingering scent associated with an orca kill appears to function as an unmistakable signal that another predator has recently hunted successfully in that location. Unlike a passing visual encounter, chemical traces can remain within the water column long after the original event has ended. For sharks entering the area afterward, the environment still carries evidence of what occurred there. Studies connected with Port and Starboard indicate that avoidance behavior can continue for weeks after the orcas have departed, as though the coastline itself continues broadcasting information about recent danger through invisible currents. Comparable observations have emerged from another ocean as well. Along the California coast, researchers documented great white sharks abandoning seasonal feeding grounds following the arrival of orcas. In some cases, the absence persisted for as long as a year before the sharks resumed their former patterns. The interruption extended well beyond a brief reaction, influencing the timing and structure of annual migrations that had previously remained remarkably stable. Taken together, these observations reveal an unusual relationship between two apex predators. Great white sharks display a deeply conditioned avoidance response to chemical evidence associated with orcas, altering movements that normally remain consistent across many seasons. No comparable flight response has been documented in the opposite direction. Within this ecological relationship, information flows one way, and so does caution, reshaping the behavior of an entire predator population long after the encounter itself has passed. Some changes announce themselves with abundance, others become visible only through absence. At Seal Island in False Bay, researchers spent years counting the familiar arrival of great white sharks, recording each season with the same methods so that every survey could be compared fairly with the last. The work unfolded patiently across changing weather, shifting currents, and countless field expeditions, gradually creating one of the longest continuous records of great white activity anywhere in the world. That monitoring program began during 2000 and remained consistent through the years that followed. By repeating standardized surveys across every season, scientists established a dependable baseline describing how a healthy aggregation site behaved over time. Annual fluctuations certainly occurred, yet they unfolded within predictable limits. Sharks arrived, departed, and returned according to rhythms that had remained recognizable for well over a decade. The value of such a record rested not only in the observations themselves, but in the confidence that genuine change would stand apart from ordinary variation. During 2015, the same year Port and Starboard entered the formal scientific record, researchers noticed that the familiar pattern was beginning to shift. Sightings around Seal Island no longer matched the expectations built from 15 years of previous surveys. At first, the difference appeared modest enough to invite caution. Marine ecosystems often experience temporary fluctuations driven by prey, availability, water temperature, or seasonal conditions. Continued monitoring, therefore, remained essential before broader conclusions could be drawn. The following years removed much of that uncertainty. Instead of recovering, the number of observed great white sharks declined with unusual speed. The pattern was directional rather than cyclical, carrying the population steadily downward instead of returning toward previous averages. By the time researchers reached 2017, the reduction had become unmistakable. The dependable gathering place that had defined so much of the region's scientific work was changing before their eyes. Then came the surveys of early 2018. The result was not merely another decrease. Researchers recorded no great white sharks at all. One of the world's most reliable aggregation sites, documented continuously for nearly 2 decades, had reached complete absence within the monitoring record. 15 years of remarkable stability had unraveled in less than 3 years, producing a transformation that extended far beyond ordinary population fluctuation. Even so, the scientific explanation remains more careful than a single dramatic cause. Investigators studying the region, including researchers associated with the Oceans Research Institute, have emphasized that the great white population had already endured sustained human pressure long before Port and Starboard became widely known. Along portions of the South African coastline, shark safety programs employed lethal nets and drumlines intended to reduce encounters between sharks and swimmers. Although designed for public protection, these measures removed sharks from the ecosystem across many decades, gradually reducing the resilience of an already vulnerable population. That historical context changes the meaning of what followed. The orcas did not arrive in an ecosystem untouched by previous disturbance. They entered one where long-term human mortality had steadily weakened the population's ability to recover from additional losses. Under those conditions, a highly specialized predator capable of consistently removing adult sharks introduced another source of mortality that the remaining population struggled to absorb. The combined pressures proved far more significant than either influence considered in isolation. Marine biologist Enrico Gennari, director of the Oceans Research Institute, had watched these waters across many years of field research. From that long perspective, the pace of ecological change stood out as one of the most remarkable aspects of the story. An entire bay reorganized within less than a decade, altering predator distributions and long-established patterns that earlier observations had suggested were comparatively stable. Nothing within the preceding 15-year record had foreshadowed such a rapid transformation. The disappearance of great white sharks from False Bay therefore became more than a local observation. It demonstrated how patiently accumulated ecological balance can shift once several pressures converge at the same time. Years of consistent monitoring gave researchers something exceptionally valuable, not only a record of what had been lost, but a detailed memory of how the ecosystem had once functioned before its familiar pattern faded from the waters around Seal Island. A food web is often imagined as a ladder, with one species standing above another. In reality, it behaves more like a woven fabric, where every strand depends upon countless others remaining under tension. When one thread is removed, the change spreads outward through connections that may seem distant from the original point. Ecologists describe this process as a trophic cascade, a chain of consequences set in motion when a predator at the highest level of an ecosystem no longer performs its familiar role. Such cascades rarely unfold under continuous observation. Marine ecosystems are vast, constantly moving, and shaped by many influences at once. Distinguishing one cause from another usually demands years of careful measurements gathered before, during, and after the change itself. False Bay happened to possess exactly that kind of scientific record. Decades of standardized surveys had preserved an unusually detailed picture of ecological stability, allowing researchers to watch an entire marine community reorganize while the evidence accumulated year after year. Before 2015, great white sharks exerted an influence extending well beyond the animals they directly hunted. Cape fur seals leaving their colonies entered waters where the possibility of encountering a great white remained ever present. That continuing risk shaped daily behavior. Travel routes, swimming patterns, feeding decisions, and time spent in exposed areas were all influenced by the persistent chance that a predator might appear. Predation affected not only survival but also the countless decisions made by animals attempting to avoid becoming prey. As great white sharks became increasingly scarce within False Bay, those behavioral constraints gradually weakened. Cape fur seals encountered fewer immediate threats while moving through waters that had once demanded greater caution. Researchers documented measurable increases in seal sightings as the years progressed, indicating that the disappearance of the dominant predator had altered both behavior and the broader dynamics influencing the local population. The absence of fear became an ecological force in its own right. Another predator also responded to the changing landscape. Broad-nosed seven-gill sharks had long shared portions of the ecosystem with great whites, sometimes competing for similar resources and occasionally becoming prey themselves. As the larger sharks withdrew, seven-gill sharks expanded into habitats that had previously remained less available. Their growing presence represented more than a simple replacement of one predator by another. They occupied a different ecological role, hunted different combinations of prey, and influenced the food web through their own distinctive feeding habits. Those changes continued spreading outward. Larger seal populations increased predation upon the schooling fish that sustain their colonies, placing greater pressure on species lower within the food chain. Expanding numbers of seven-gill sharks likewise increased hunting pressure upon smaller sharks and other bottom-dwelling animals occupying coastal habitats. The consequences, therefore, did not remain confined to great white sharks alone. Every shift produced another response somewhere else, extending the cascade through multiple levels of the ecosystem. Marine ecologist Neil Hammerschlag and colleagues documented these relationships through research published in the journal Frontiers in Marine Science. Their analysis connected declining great white shark presence with increasing sightings of Cape fur seals and broad-nosed seven-gill sharks, while simultaneously identifying reductions among species hunted by those expanding predators. Rather than existing as isolated observations, the changes formed a coherent ecological sequence consistent with the principles of a trophic cascade observed under unusually favorable scientific conditions. Perhaps the most remarkable feature was not the direction of change, but its pace. Ecological theory has long recognized that removing an apex predator can reshape an ecosystem, yet many models envisioned such restructuring unfolding over considerably longer periods. False Bay demonstrated that, under the combined pressures already affecting the region, an entire marine food web could measurably reorganize in less than a decade. Years of continuous monitoring transformed what might otherwise have remained scattered anecdotes into one of the clearest documented examples of large-scale ecological restructuring ever recorded in the ocean, revealing how the influence of a single predator can continue flowing through countless lives long after that predator itself has largely disappeared from familiar waters. Protection is often imagined as a boundary drawn upon a map, a line separating vulnerable places from harmful ones beyond. Oceans seldom recognize such borders. Their inhabitants follow food, temperature, memory, and instinct rather than legal designations. When relationships among predators begin to change, those invisible movements pass effortlessly through the limits established by human management, carrying consequences into places that were created specifically to preserve ecological balance. As Cape fur seal numbers increased following the departure of great white sharks from False Bay, the effects spread beyond predators alone. Every additional seal required food, and the foundation of that diet remained the dense schools of small fish moving through coastal waters. For many years, the constant possibility of encountering great white sharks had helped shape where and how seals searched for prey. Once that persistent pressure diminished, larger numbers of seals could forage with fewer interruptions, increasing the overall demand placed upon the same fish populations. Researchers studying False Bay documented declines among several schooling fish species during the years following the disappearance of great white sharks. Marine ecosystems are influenced by weather, commercial fishing, ocean temperatures, and many interacting biological forces, making simple explanations difficult. Even so, the observed pattern remained consistent with expectations produced by a trophic cascade. Larger seal populations consumed greater quantities of fish, extending ecological consequences another step farther down the food web. The influence of the missing apex predator continued reaching species that never directly encountered a great white shark. Among the animals affected by these shifting relationships was the African penguin, known scientifically as Phoeniscus demersus. Unlike seals, penguins do not hunt sharks or compete with them directly. Their connection exists through shared prey. African penguins depend upon many of the same schooling fish sought by Cape fur seals, placing both species within the same energetic network. As seals increased their consumption, the competition facing penguins also intensified, leaving fewer opportunities to obtain sufficient food for themselves and their developing young. The timing carried particular significance because African penguins had already experienced severe population declines long before these ecological changes unfolded. Since 2000, their overall numbers have fallen by roughly 70%, leading to their recognition as an endangered species. Such declines result from multiple pressures, including changing ocean conditions, historical harvesting, commercial fishing, and reduced prey availability. The restructuring of the False Bay food web, therefore, emerged not as an isolated challenge, but as another influence acting upon a species already struggling to recover. Scientists continue monitoring breeding colonies at Boulders Beach and St. Denis Point, both located within or adjacent to the waters of False Bay. Researchers measure breeding success, chick survival, and changing patterns of food availability, while examining whether broader ecosystem shifts contribute to long-term reproductive outcomes. Establishing direct ecological relationships requires careful evidence gathered across many seasons, yet the importance of maintaining these observations has only grown as the marine community continues adjusting to altered predator dynamics. Ironically, these developments unfolded inside the False Bay Marine Protected Area, a legally designated conservation zone established to safeguard one of South Africa's most significant coastal ecosystems. The reserve was created with the expectation that preserving habitat and limiting harmful human activities would strengthen the natural relationships among species living there. Its design reflected established ecological understanding, assuming that the long-standing hierarchy of predators would remain fundamentally stable across time. Port and Starboard introduced a circumstance that no management plan had anticipated. The challenge did not arise because protection had failed to exist. Instead, it emerged because conservation boundaries cannot prevent knowledge from spreading through intelligent predators or stop ecological relationships from changing once behavior itself evolves. A marine reserve can reduce fishing pressure, preserve habitat, and regulate human activity, yet it cannot instruct wild animals to continue occupying familiar roles within an ecosystem. For conservation scientists, False Bay has therefore become an important living case study. The events documented there demonstrate that protecting an ecosystem depends upon more than protecting the space it occupies. Stability also rests upon the intricate relationships connecting every species within that space. When those relationships shift rapidly from the highest level of the food web, even a carefully protected marine reserve can begin transforming faster than scientific expectations, management strategies, or legal frameworks were ever designed to accommodate. Maps often suggest that movement creates distance from danger. A coastline appears as a succession of separate bays, each with its own identity, inviting the impression that leaving one place means entering another untouched by what came before. Marine predators experience the ocean differently. Productive feeding grounds are connected by currents, migrations, and memory, allowing hunters to trace the same pathways followed by the animals they pursue. As great white sharks became increasingly scarce within False Bay and Gansby, Port and Starboard did not remain tied to the waters where they had first drawn scientific attention. Their movements expanded eastward along the South African coast, extending roughly 150 miles toward Mossel Bay. The shift revealed that their hunting behavior was not confined to a single, familiar location. Instead, they ranged across distant sections of coastline, following opportunities wherever they emerged. Evidence of that expansion appeared during August of 2022. A great white shark carcass washed ashore near Mossel Bay, bearing the same distinctive opening at the pectoral girdle that researchers had already come to recognize elsewhere. The timing proved especially significant because a pod of orcas had been observed cruising through the area only one day earlier. The sequence connected observations separated by only a brief interval, strengthening the conclusion that the specialized hunting pattern had reached another important aggregation site for great white sharks. The movement carried an ecological meaning extending beyond the loss of a single shark. Earlier changes in False Bay and Gansby might have suggested that displaced great whites could establish themselves in neighboring regions beyond the reach of the hunting orcas. Mossel Bay demonstrated a different reality. As sharks shifted into another productive habitat, Port and Starboard appeared there as well. The redistribution of prey had been matched by a redistribution of predators, reducing the possibility that relocation alone could provide lasting refuge. This flexibility reflects the broader natural history of killer whales. Unlike species that defend relatively fixed territories throughout life, many killer whale populations travel immense distances while tracking seasonal food resources. Their movements are shaped less by geographic boundaries than by the changing distribution of prey. Port and Starboard fit comfortably within that larger pattern. Their appearances across widely separated portions of the South African coastline suggest animals responding to opportunities spread across an extensive marine landscape rather than remaining attached to one particular bay. Documented observations now place their range from the waters bordering Namibia in the northwest to Port Elizabeth in the east. Together, those records encompass several thousand miles of coastline, illustrating that these two individuals operate across an extraordinary geographic scale. Such mobility allows specialized hunting knowledge to influence ecosystems separated by great distances, linking locations that might otherwise appear independent when viewed only on a map. For great white sharks, this mobility alters the meaning of migration itself. Seasonal movements have long enabled sharks to exploit changing food supplies while avoiding less favorable conditions. When an adaptable predator can travel across much of the same coastline, familiar destinations may no longer provide the predictability they once offered. The relationship becomes dynamic, with both hunter and hunted adjusting their movements in response to one another across hundreds of miles of ocean. Researchers observed that great white sharks eventually returned to Mossel Bay after the initial disruption, yet their presence differed from earlier years. Fewer individuals occupied the area, and those that did remained for shorter periods before moving on again. The pattern suggested a cautious reoccupation rather than a complete restoration of former behavior. Sharks continued using valuable habitat, but they appeared less willing to linger within it. These observations reveal a landscape where movement itself has become part of the ecological balance. Productive coastal waters still attract great white sharks, just as they have for countless generations. Yet the specialized hunting strategy developed by Port and Starboard travels across many of those same routes. Instead of remaining anchored to one celebrated location, the story broadens into a coastline connected by migration, memory, and pursuit, where each return to familiar waters unfolds beneath the possibility that the hunters have already arrived. Knowledge in the ocean often leaves no written record. It survives instead through repeated actions carried from one generation to another by observation, memory, and shared experience. A feeding ground becomes a classroom without walls, where successful behavior is witnessed rather than explained. For many years, the remarkable hunting associated with Port and Starboard appeared to belong only to those two distinctive males. Then the view from above revealed something entirely new. During October of 2022, researchers flying drones above the waters near Mossel Bay captured the first visual evidence of coordinated hunting behavior matching the pattern that scientists had previously reconstructed from recovered shark carcasses and scattered eyewitness observations. Until that moment, the sequence itself had largely remained hidden beneath the surface. Investigators understood its results through careful forensic examination, yet they had never watched the critical movements unfold from beginning to end in a way that could be studied repeatedly. The aerial footage showed 5 killer whales working together around a great white shark. Their movements displayed a level of coordination consistent with the specialized approach already associated with port and starboard. Individuals positioned themselves deliberately, responding to one another as the encounter developed, rather than acting as unrelated hunters pursuing the same prey. The scene transformed years of indirect evidence into direct visual documentation, connecting observations made from shorelines with behavior recorded in the open sea. The following day, another great white shark washed ashore bearing the now familiar opening near the pectoral girdle and the selective removal of its liver. Once again, physical evidence aligned with events documented shortly beforehand. The timing strengthened the connection between the observed hunting behavior and the distinctive injuries that had become recognizable across multiple years of scientific investigation. Perhaps the most important feature of the encounter was not the shark itself, but the number of participating killer whales. The group included more than port and starboard alone. Additional individuals had taken part in behavior that researchers had once regarded as unique to 2 exceptional animals. That observation suggested the specialized hunting method was no longer confined to its earliest documented practitioners. Instead, it appeared to be expanding within the regional killer whale community. Such expansion fits remarkably well with what scientists already understand about killer whale culture. These animals learn many foraging traditions through prolonged association with companions. Young or less experienced individuals spend years accompanying older whales, observing successful hunts while gradually participating in them. Skills need not be deliberately demonstrated through formal instruction. Simply remaining present during repeated feeding events provides opportunities to witness the sequence of actions, experience the timing required, and share in the nutritional reward that follows success. This process creates an efficient pathway for behavioral transmission. A younger whale watching an experienced hunter isolate a shark, manipulate its body, and gain access to the energy-rich liver receives both practical information and immediate reinforcement. The technique becomes associated with a substantial nutritional benefit. Over many encounters, observation can gradually become participation, and participation can eventually become independent performance. Field observations made elsewhere along the South African coastline after 2022 added another intriguing layer to the emerging picture. Researchers documented individual killer whales hunting sharks in regions where port and starboard had previously been active. Some encounters involved solitary animals rather than coordinated pairs or larger groups. Although every case cannot be linked directly to earlier observations, the growing pattern is consistent with individuals applying a hunting strategy they may have acquired while accompanying more experienced whales. The significance extends beyond the biographies of 2 famous predators. Once a learned behavior begins moving through a social population, its future no longer depends entirely upon the original innovators. It can persist as long as opportunities for observation and successful repetition continue. Cultural traditions among killer whales have demonstrated remarkable durability in many parts of the world, sometimes remaining recognizable across generations through shared feeding techniques, vocal patterns, and preferred prey. For that reason, Port and Starboard may represent not the conclusion of an extraordinary story, but the beginning of a broader cultural transformation within South African killer whales. The available evidence indicates that the specialized method of hunting sharks has already spread beyond its earliest known practitioners, while the full extent of that transmission remains only partially visible, still unfolding across a coastline where observation continues to reveal new chapters, one encounter at a time. Scientific discoveries sometimes become most important when they reveal that an unusual event is not truly isolated. A behavior once thought to belong to one remarkable place begins appearing somewhere entirely different, connected not by geography, but by striking similarity. As observations accumulate across distant oceans, individual stories gradually merge into a broader pattern, inviting researchers to reconsider what they believed they understood about the limits of animal culture. During November of 2025, a peer-reviewed study published in Frontiers in Marine Science added exactly such a piece to the growing puzzle. The research focused not on South Africa, but on the Gulf of California in Mexico, roughly 8,000 miles away across another ocean basin. There, a well-known group of killer whales called Moctezuma's pod had been documented performing a hunting sequence that closely matched the specialized behavior previously associated with Port and Starboard. The observations drew upon two separate encounters, one recorded during 2020 and another during August of 2022. In both cases, researchers documented several killer whales coordinating their movements around juvenile great white sharks. Working together, they rammed the sharks, overturned them into an inverted position, induced tonic immobility, and gained access to the liver through the same vulnerable region of the body. The sequence unfolded with remarkable consistency, despite occurring on the opposite side of the continent. The observations did not end with the successful capture of prey. Researchers also documented the extracted livers being shared among adults and young calves within the pod. Such feeding behavior carries particular importance because it places inexperienced animals directly alongside experienced hunters during the moment when both technique and reward become linked. Calves witness the sequence, participate in the feeding, and encounter the nutritional value of the liver within the same social setting. Cultural knowledge is therefore reinforced through shared experience rather than formal instruction. What makes this discovery especially compelling is the apparent isolation between the two killer whale populations. Moctezuma's pod has no documented contact with Port and Starboard, or the whales accompanying them along the South African coastline. The Atlantic Ocean separates the regions, while the immense distance around the southern tip of the continents provides no known pathway through which specialized hunting traditions could realistically spread between these particular communities. Current evidence offers no mechanism by which one population could simply teach the other. South Africa and Mexico are not the only places contributing evidence. Australian waters provide another important point of comparison. Earlier genetic analyses had already confirmed that killer whales prey upon great white sharks there as well, although direct observations remain less complete than those available from South Africa or the Gulf of California. The evidence indicates another geographically distinct population interacting with the same formidable prey through a fundamentally similar outcome. Taken together, these findings present scientists with two intriguing possibilities. One is that specialized shark hunting has existed within multiple killer whale populations for far longer than researchers realized, remaining largely undocumented because opportunities to observe such rare events have been limited. South Africa may simply represent the region where unusually extensive monitoring, recovered carcasses, and long-term ecological studies happen to preserve the clearest scientific record. The second possibility is equally remarkable. Independent killer whale populations may have arrived at essentially the same solution without any direct cultural connection between them. Faced with the same prey, possessing comparable intelligence, social learning, and observational abilities, they could have recognized the neurological vulnerability created by tonic immobility and gradually transformed that discovery into an organized hunting strategy. Evolution often produces similar adaptations in unrelated species, confronting similar environmental challenges. And culture itself may occasionally follow comparable pathways when minds capable of innovation encounter the same problem. Whichever explanation ultimately proves correct, the meaning of port and starboard changes in an important way. Rather than standing apart as two inexplicable individuals, they become the most carefully documented representatives of a phenomenon extending across multiple oceans. Their story no longer belongs only to South Africa. It becomes part of a larger narrative exploring how intelligence, cooperation, and cultural learning continue shaping the lives of killer whales on a truly global scale. Intelligence is often measured by what can be seen: a hand shaping a tool, a bird weaving a nest, or a primate solving a puzzle fits comfortably within the ways humans have long compared minds across species. Beneath the ocean's surface, evidence is more difficult to gather. Behavior disappears beneath shifting water, leaving researchers to reconstruct thought from movements that last only moments before fading from view. Yet some sequences are so intricate that they invite careful reflection about the mental processes required to produce them. The hunting method associated with port and starboard belongs among those sequences. It begins with locating a moving shark beneath the surface through echolocation, capable of resolving position in three-dimensional space, while both hunter and prey remain in motion. The information gathered must be updated continuously as the shark changes direction, depth, and speed. Unlike an object resting on the seafloor, a living predator responds unpredictably, requiring constant adjustment throughout the encounter. From there, the challenge shifts from perception to coordination. Two killer whales must synchronize their actions with remarkable precision, approaching from advantageous positions while avoiding one another and anticipating the movements of the shark itself. Success depends upon striking with timing accurate enough to disrupt the shark before it can mount an effective response. The opportunity exists only briefly, demanding cooperation that has clearly been refined through repeated experience rather than spontaneous improvisation. Once the shark has been overturned, another level of precision becomes necessary. The liver cannot simply be reached through any opening. The whale must direct its efforts toward a specific anatomical region near the pectoral girdle, creating an access point that allows removal of the organ while leaving much of the surrounding body relatively intact. Repeating this outcome across many documented encounters suggests familiarity with the internal structure of an animal that differs profoundly from the killer whale itself. The sequence also requires sustained attention across multiple stages. Detecting the prey, coordinating pursuit, inducing tonic immobility, accessing the liver, and completing the feeding event all occur within a dynamic marine environment where currents, visibility, and the actions of nearby companions continually change. Each stage depends upon the successful completion of the one before it. Interruptions or errors at any point could allow the shark to recover or escape, making consistency especially revealing. Researchers therefore view this behavior as learned rather than instinctive. Instinct can guide broad tendencies, Yet highly specialized procedures generally emerge through experience, refinement, and repeated success. Across approximately 8 years of documented observations, Port and Starboard demonstrated an extraordinary level of consistency. Their behavior retained the same essential structure despite differences in location, prey, and circumstance. Such stability reflects mastery built through repetition rather than isolated moments of invention. Comparisons with other intelligent animals help illustrate the scale of this achievement while remaining respectful of the unique strengths found across different species. Chimpanzees, widely recognized among the most cognitively sophisticated land animals, display remarkable problem-solving abilities and documented tool use, including selecting and modifying slender sticks to extract insects from narrow openings. These behaviors reveal planning, dexterity, and learning, yet they generally involve a comparatively direct sequence centered upon a single object and a single immediate objective. The shark hunting strategy, developed by Port and Starboard, unfolds across many interconnected stages without relying upon a manufactured tool. Instead, the whales integrate detailed spatial mapping, cooperative timing, anatomical precision, energetic efficiency, memory, and communication into one coordinated procedure. The same fundamental pattern has now been documented repeatedly and has begun appearing in other killer whale populations separated by immense distances, suggesting that the underlying knowledge can persist beyond the individuals who first demonstrated it. These observations have encouraged scientists to examine whether traditional frameworks for evaluating animal intelligence fully capture the capabilities of highly social marine mammals. Many influential measures of cognition were originally shaped through studies of terrestrial species whose environments differ profoundly from life beneath the ocean. Killer whales navigate a world where sound replaces sight across vast distances, cooperation unfolds in 3 dimensions, and culture passes through enduring family relationships. Their accomplishments invite a broader understanding of intelligence, one that recognizes sophisticated minds need not resemble our own to reveal astonishing depths of thought. Brains can be compared by weight, by shape, or by the number of cells they contain, yet those measurements reveal only part of the story. The true significance of a brain emerges through the patterns it makes possible, the memories it preserves, the relationships it sustains, and the behaviors it allows to unfold across a lifetime. After following the remarkable hunting traditions of killer whales across oceans and generations, it becomes natural to look inward toward the organ that supports such extraordinary lives. An adult killer whale carries one of the largest brains found in any living animal. It weighs approximately 15 pounds, nearly 4 times the average mass of a human brain. Size alone does not determine intelligence, since elephants and several whale species also possess enormous brains for reasons partly related to their equally massive bodies. Even so, the internal organization of the killer whale brain has drawn increasing scientific attention because its complexity extends well beyond simple scale. Researchers estimate that the killer whale brain contains roughly 43 billion neurons, compared with approximately 21 billion in the human brain. Neurons form the communication network through which perception, memory, movement, and thought emerge. Numbers alone cannot establish intellectual ability, yet they illustrate the immense processing capacity available within the nervous system of an animal already known for sophisticated social lives, cooperative hunting, and enduring cultural traditions. The cerebrum occupies more than 81% of the total brain volume. Covering its surface lies a neocortex folded into an intricate landscape of ridges and grooves. These folds greatly expand the amount of cortical tissue that can fit within the limits imposed by the skull. Human brains rely upon the same structural principle, increasing processing capacity by packing additional surface area into a finite space. In killer whales, that folding reaches an even greater degree than overall skull size would appear to predict, suggesting a cortex organized for extensive information processing. Among the most intriguing discoveries came during the early years of the 21st century, when researchers confirmed the presence of spindle neurons, also known as von Economo neurons, within the brains of cetaceans, including killer whales. In humans, these specialized cells are associated with rapid intuitive judgments, complex social awareness, empathy, and aspects of self-awareness. Their presence in killer whales does not imply identical mental experiences, yet it demonstrates that evolution has produced remarkably similar cellular machinery in two very different evolutionary lineages. Scientists continue investigating exactly how these neurons contribute to cetacean cognition. Even more distinctive is a region called the paralimbic lobe. This structure has no known equivalent within the human brain, nor has it been identified in other primates or any other animal studied to the same extent. Researchers believe it participates in integrating emotion, bodily sensation, and social information, although its precise functions remain uncertain. The absence of a comparable structure leaves neuroscience without a direct model, making interpretation especially challenging. Killer whales may therefore process aspects of experience using neural architecture unlike anything documented in terrestrial mammals. Other emotional centers also stand out. The insular cortex, often associated in humans with empathy, emotional awareness, and the perception of internal bodily states, occupies a proportionally larger region in killer whales than has been reported in any other known species. Such enlargement cannot be translated directly into specific emotions, yet it reinforces the growing picture of an animal whose social life depends upon exceptionally sophisticated emotional processing. Behavioral observations complement these anatomical discoveries. Killer whales have demonstrated mirror self-recognition, a widely accepted indicator of self-awareness documented in only a small number of species, including humans, great apes, elephants, bottlenose dolphins, and killer whales. Young calves also learn the distinctive vocal dialects of their own pods through extended periods of practice. Early calls emerge imperfectly before gradually becoming more accurate, following a developmental pattern that researchers often describe as structurally analogous to the way human children acquire language. Together, these anatomical and behavioral discoveries suggest minds shaped not only for survival, but for relationships, memory, communication, and cultural continuity across generations. The word culture is usually reserved for humanity. It evokes languages, traditions, customs, and knowledge carried across generations through learning rather than inheritance. For many years, applying that same word to another species seemed unnecessarily generous. As research accumulated across decades, however, marine biologists found themselves reaching an unexpected conclusion. The behaviors observed among killer whales satisfied the scientific definition of culture with remarkable precision, not as metaphor, but as measurable biological reality. Within behavioral science, culture refers to socially transmitted traditions that differ between populations, persist across generations, and cannot be explained solely by genetic inheritance or differences in habitat. Learned behaviors spread through observation, imitation, and prolonged association, becoming part of a community's identity. Killer whales fulfill each of those requirements. Distinct populations maintain different ways of hunting, communicating, and organizing their societies, despite sharing the physical ability to perform many of the same behaviors. Along the Pacific Northwest coast, resident killer whales illustrate this principle with extraordinary consistency. These whales feed almost exclusively upon fish, especially Chinook salmon, following seasonal migrations that have shaped their lives for countless generations. They travel in large, multi-generational family groups centered upon enduring maternal lineages. Every pod possesses its own vocal dialect, learned gradually during development and recognizable to neighboring groups. Young whales spend years accompanying older relatives, absorbing specialized methods of locating, pursuing, and capturing fish through repeated participation in daily life. Sharing many of the same coastal waters are transient killer whales, also known as Biggs killer whales. Although they are genetically capable of interbreeding with resident populations, they rarely do. Their culture has taken an entirely different path. Rather than pursuing fish, they specialize in hunting marine mammals such as seals, sea lions, dolphins, and occasionally larger whales. Because these prey species possess acute hearing beneath the surface, transient groups travel with far fewer vocalizations while hunting. They usually form smaller groups than residents, reflecting the different demands imposed by stealth. Their social structure, communication patterns, and feeding traditions differ so profoundly that cultural separation now functions as an effective biological boundary despite the absence of physical barriers. Far to the south, Antarctic waters reveal even greater diversity. Scientists have identified at least 5 distinct killer whale ecotypes occupying the same broad region while employing different hunting traditions. One group practices coordinated wave washing, approaching floating ice in synchronized formation before generating a powerful surge that sweeps resting seals into open water. Success depends upon multiple whales contributing precisely timed movements that no individual could accomplish alone. Another ecotype has been documented coordinating attacks upon adult blue whales, with different individuals assuming complementary roles as the hunt unfolds. Such encounters require prolonged cooperation and flexible coordination rather than simple simultaneous pursuit. Along the coast of Argentina, another remarkable tradition has endured for generations. Killer whales intentionally strand themselves upon sloping beaches to seize sea lions gathered near the water's edge. The maneuver carries genuine danger because a miscalculation can leave a whale trapped beyond the reach of returning waves. Young whales, therefore, do not master the behavior independently. Older animals accompany them through repeated practice, and researchers have documented adults physically assisting juveniles that become stranded while learning. Experience passes gradually from one generation to the next through direct participation in carefully repeated attempts. Taken together, these examples reveal populations solving similar ecological challenges through entirely different traditions. Fish specialists, marine mammal hunters, wave-washing experts, intentional stranders, and shark specialists all belong to the same species. Yet each community preserves knowledge that neighboring populations may never develop. These differences cannot be dismissed as simple responses to local conditions because nearby groups often inhabit overlapping environments while maintaining distinct behaviors across many generations. Viewed in that broader context, the hunting strategy associated with Port and Starboard becomes part of a much larger story. Their remarkable precision is not merely an isolated display of intelligence. It represents another chapter in the rich cultural diversity of killer whales, a species whose greatest evolutionary advantage may lie not only in powerful bodies or sophisticated brains, but in the enduring ability to preserve knowledge, refine it through experience, and pass it from one generation to the next, until tradition itself becomes a tool for survival. Names in biology often appear permanent, yet they are better understood as working descriptions that change when evidence grows. Every generation of scientists inherits a system for organizing life, then adjusts that system when nature refuses to fit comfortably within its categories. Killer whales now occupy one of those fascinating places where long accepted definitions are being reconsidered, not because earlier researchers were careless, but because decades of observation have revealed a level of diversity that was once almost impossible to detect. For much of modern science, all killer whales have been classified within a single species, despite their extraordinary range and ecological variety. As field studies expanded across the world's oceans, however, differences between regional populations became increasingly difficult to dismiss as simple local variation. Distinct hunting traditions, vocal dialects, body proportions, dietary preferences, and social organization persisted over generations, even where different populations occupied overlapping waters. These discoveries prompted a growing number of researchers to ask whether some killer whale populations should eventually receive recognition as separate species. The discussion begins with the biological species concept, one of the most widely used frameworks in taxonomy. According to this definition, members of the same species are capable of producing fertile offspring together. By that standard, killer whale ecotypes remain one species. Their genetic makeup is sufficiently compatible that successful reproduction is theoretically possible. From a purely biological perspective, the boundaries separating them have not become complete reproductive barriers. Another framework approaches the question from a different direction. The behavioral species concept places greater emphasis upon the practical realities of social life, particularly among highly intelligent animals whose identities are shaped by learning rather than genetics alone. Under this view, the meaningful boundary between populations may be defined by shared traditions, communication, and social membership. Groups that no longer exchange culture, rarely interbreed in practice, maintain separate diets, develop distinct vocal systems, and organize themselves according to different social rules, may function as separate evolutionary units, even while retaining the biological capacity to produce offspring. Killer whales present an unusually compelling example because many of these divisions occur without obvious geographic isolation. Resident and transient populations of the Pacific Northwest move through many of the same coastal waters, yet maintain striking cultural separation. Their feeding traditions differ completely. Their dialects remain distinct. Their family structures follow different patterns. Encounters between the groups rarely lead to social integration, and successful interbreeding appears exceptionally uncommon despite countless opportunities across many generations. Culture has even begun leaving measurable marks upon anatomy itself. Offshore killer whales, which specialize in hunting sharks, display characteristic patterns of tooth wear, unlike those found in populations feeding primarily upon fish or marine mammals. Shark skin is covered with countless tiny tooth-like scales called dermal denticles, creating a remarkably abrasive surface. Over the course of a lifetime, repeated contact with this rough skin gradually grinds away tooth enamel, producing a recognizable physical signature. The difference does not arise from inherited anatomy alone. It develops because a culturally transmitted dietary specialization exposes individuals to the same demanding feeding behavior year after year. This relationship between learned tradition and physical change offers an intriguing glimpse into evolution unfolding through behavior. A population adopts a distinctive hunting strategy. That strategy determines diet. Diet influences patterns of wear, energy intake, movement, and eventually perhaps even natural selection acting across many generations. Culture becomes more than an expression of intelligence. It begins shaping biology itself, blurring the familiar boundary between learned behavior and evolutionary change. No formal scientific consensus has yet emerged regarding whether particular killer whale ecotypes deserve recognition as separate species. Taxonomists continue examining genetic evidence, anatomy, ecology, behavior, and long-term reproductive patterns before reaching such consequential decisions. The debate remains active precisely because the evidence refuses to point toward an easy answer. That uncertainty is meaningful in its own right. It suggests that Port and Starboard may represent more than two extraordinary individuals displaying an unusual hunting technique. They may belong to a lineage whose specialization upon sharks extends deeply enough through shared history and cultural inheritance to leave enduring marks upon their bodies, their behavior, and perhaps eventually the very way science classifies their place within the living world. Among the many features that define a killer whale, none is more immediately recognizable than the tall dorsal fin rising above the water. From a distance, it appears almost rigid, as though carved from solid material. That impression is deceptive. Beneath the smooth black surface lies neither bone nor cartilage. Instead, the fin is formed almost entirely from dense, fibrous, connective tissue composed primarily of collagen, a flexible framework whose shape depends as much upon the surrounding environment as upon the tissue itself. During ordinary life in the open ocean, water flowing around a swimming killer whale provides continuous hydrodynamic support. Movement through deeper water helps maintain the fin's upright profile, distributing forces across its collagen fibers as the animal travels, dives, and turns. Rather than standing by its own internal rigidity, the dorsal fin exists in constant partnership with the water surrounding it. The ocean itself becomes part of the structure that keeps the fin erect. Captive environments alter that relationship in fundamental ways. Killer whales living in marine parks spend much of their time close to the surface, where the fin remains exposed to gravity without the same hydrodynamic support experienced during prolonged swimming through deeper water. Studies have estimated that captive individuals may remain near the surface for roughly 70 to 80% of their time. Over years, the collagen gradually weakens, and the fin bends or collapses under its own weight. Nearly every adult male held in captivity eventually develops this condition, making the drooping dorsal fin one of the most widely recognized visual symbols in discussions surrounding the welfare of captive killer whales. The picture in the wild is dramatically different. Fewer than 1% of free-ranging killer whales display a fully collapsed dorsal fin. When the condition does occur, it is most often associated with severe injury, significant illness, or the gradual physical changes accompanying exceptional old age. For decades, seeing such a fin in nature generally suggested that the animal carrying it was no longer in peak condition. Port and Starboard stand in remarkable contrast to that expectation. Across at least 8 years of documented observations, they have ranged over thousands of miles of coastline while repeatedly hunting great white sharks, measuring approximately 15 feet in length. Their movements have shown no obvious sign that collapsed dorsal fins reduce their effectiveness as predators. They continue traveling extensively, coordinating sophisticated hunts and influencing the behavior of other apex predators across a vast marine landscape. Whatever aerodynamic disadvantage the altered fin might create has not produced limitations detectable within the scientific record assembled so far. One explanation has gradually gained support among researchers. The two males may simply be considerably older than their appearance alone suggests. If so, natural aging rather than disease could account for the collapse of their dorsal fins. Age also offers an intriguing perspective on their unusual specialization. Hunting swift marine mammals often demands prolonged high-speed pursuit, whereas a carefully executed shark hunt, once tonic immobility has been induced, may provide a substantial nutritional reward through a sequence emphasizing precision more than endurance. Such a transition would represent not decline, but adaptation, allowing experienced hunters to capitalize upon knowledge accumulated across decades. Even this interpretation remains only a hypothesis. No scientist has determined the precise age of either whale. Their birth dates are unknown, their early histories remain hidden, and the reasons their dorsal fins collapsed cannot yet be demonstrated with certainty. As with the mystery surrounding their origins, important pieces of the story remain beyond the reach of observation. Perhaps the greatest irony lies in the unintended consequence of those distinctive fins. In most wild killer whale populations, recognizing a particular individual requires years of photographs, careful comparisons of saddle patches, scars, and subtle markings. Port and Starboard require none of that painstaking work. Their opposing collapsed dorsal fins allow confirmation from remarkable distances, making them instantly recognizable to researchers, photographers, and experienced observers alike. The feature that should have signaled physical decline instead became the unmistakable signature of two of the most effective and closely studied wild predators ever documented. Every well-documented story has a beginning, yet some beginnings exist only as faint outlines assembled long after the events themselves have passed. Scientists often reconstruct the earliest chapters of an animal's life through photographs, field notes, recordings, and careful comparisons made years apart. Sometimes those fragments align into a complete history. Sometimes they reveal only how much remains beyond observation. Port and Starboard belong to the second kind of story, where the farther one looks into the past, the more the trail dissolves. The earliest known evidence matching the distinctive appearance of these two males comes from the coast of Namibia near Lüderitz during approximately 2009. Even that date carries an important qualification. Researchers did not recognize the whales at the time the photographs were taken. Instead, the identification happened years later after Port and Starboard had already become familiar through their activities farther south. Earlier images were revisited, distinctive dorsal fins were compared, and the realization emerged that the pair had been recorded long before anyone understood their significance. Before those photographs, the scientific record falls away. No confirmed sighting has been connected to them. No acoustic recording has been matched to their presence. No archived image collected from previous surveys has been confidently identified as showing either whale. Their lives before that point remain entirely undocumented, leaving an unknown span of years during which they undoubtedly hunted, traveled, learned, and formed the experiences that eventually shaped the remarkable behavior later observed along the South African coastline. It would be tempting to interpret this absence as evidence that the whales themselves were absent, Yet the history of marine research advises caution. Southern African killer whales have never been monitored with the same continuity achieved in portions of the North Pacific or around parts of Antarctica. Long before Port and Starboard attracted scientific attention, significant gaps already existed throughout the regional record. Survey effort varied widely across years. Vast stretches of coastline received only occasional observation, and many encounters undoubtedly passed without documentation. The missing history may therefore reflect limitations of human observation rather than any unusual movement by the whales themselves. Genetics has not yet resolved the mystery. No confirmed genetic sample from either Port or Starboard has been matched to a known family group within existing regional databases. Without such evidence, researchers cannot confidently identify close relatives, determine maternal lineage, or place the pair within a documented social history. Their ancestry remains scientifically unplaced, leaving their family connections hidden beyond the reach of present knowledge. The origin of their specialized hunting behavior remains equally uncertain. One possibility is that the technique emerged through independent innovation. An accidental encounter with an inverted shark might have revealed an unexpected vulnerability, encouraging repeated experimentation until a reliable hunting sequence gradually evolved through experience. Another possibility reaches further into the unseen past. The whales may have learned the behavior from individuals or populations that escaped scientific observation altogether. A third explanation suggests that specialized shark hunting has existed much longer and across a broader geographic range than documented evidence presently indicates, with Port and Starboard becoming famous simply because researchers happen to observe them more closely than others. Dr. Simon Elwin of Sea Search, one of the scientists most familiar with killer whales inhabiting southern African waters, has spoken openly about this uncertainty. He has suggested that the pair probably originated somewhere beyond the region where they later became famous, perhaps along the coast of West Africa, perhaps near East Africa, perhaps within the vast reaches of the Southern Ocean. His conclusion remains deliberately restrained because the available evidence supports no single destination with confidence. That enduring uncertainty has become part of their scientific identity. Years of observation have revealed how they hunt, how they influence ecosystems, and how their behavior reshaped understanding of killer whale culture. Yet the opening chapter of their lives remains unwritten. Their story begins, and in one profound sense continues, with an unanswered mystery, where they first entered the ocean's living traditions, and what experiences transformed two unrecorded whales into the most recognizable shark hunters ever documented. Predators usually influence the places where they are physically present. Their reach extends only as far as their movements carry them, fading once they disappear beyond the horizon. Port and Starboard reveal a rarer phenomenon. Their greatest ecological influence sometimes begins only after they have already departed, leaving behind an invisible presence that continues reshaping the behavior of other animals long after the water above them has become empty. When a great white shark is killed and its liver removed, large quantities of nutrient-rich oil disperse into the surrounding sea. That oil carries more than energy. It also becomes part of a complex chemical signature released into the water column, one associated with a successful killer whale attack. Ocean currents gradually dilute the mixture, yet for an extended period, the water continues bearing molecular evidence that a fatal encounter recently occurred. The event itself has ended, but the sea continues carrying its memory. Researchers studying the response of great white sharks discovered something deeply unexpected. Sharks entering these waters frequently abandon the area despite the complete absence of nearby killer whales. In some documented cases, Port and Starboard had already traveled away from the location days earlier. Even so, arriving sharks responded with the same rapid evacuation observed during direct encounters. Feeding grounds occupied over many years were deserted with remarkable speed, as though the danger remained immediately present despite the hunters having vanished beyond the coastline. This reaction emerges through one of the shark's greatest evolutionary strengths. The sense of smell possessed by great white sharks ranks among the most refined in the marine world. Tiny concentrations of biologically important compounds can be detected across immense volumes of water, allowing sharks to locate injured prey, follow feeding opportunities, and navigate dynamic ocean environments. The same remarkable sensory ability now works in reverse. Rather than guiding the shark toward food, it detects the lingering chemical evidence of a predator capable of hunting the hunter. In that moment, the water itself becomes a source of information. Long after waves have erased every visible trace of the encounter, dissolved molecules continue transmitting a biological message. The shark does not witness an attack. It does not hear approaching echolocation or observe the outline of a dorsal fin. Instead, it encounters what the ocean has retained and responds with immediate departure before another encounter can occur. Comparable patterns have appeared far beyond southern Africa. Research conducted along the California coast found that seasonal feeding grounds were abandoned after killer whales entered the region. Great white sharks remained absent for as long as a year before gradually returning. Such prolonged avoidance disrupted annual behavioral cycles and reduced the amount of time available for feeding during seasons when prey abundance normally reached its highest levels. A relatively brief appearance by killer whales therefore produced ecological consequences extending across many months. Perhaps even more remarkable is the apparent durability of the response itself. Repeated exposure does not seem to diminish its effectiveness. Sharks that have encountered killer whale-associated chemical cues multiple times continue reacting with the same decisive withdrawal. Scientists have found little evidence that individuals gradually become accustomed to the signal or learn to ignore it. Each new encounter appears to activate the same deeply rooted behavioral response, regardless of previous experience. For Port and Starboard, this creates an influence extending well beyond the limits of their physical movements. Every successful hunt leaves behind an expanding chemical landscape that suppresses shark activity after the whales have already continued along the coastline. Weeks may pass, sometimes even months, while the ecological effects remain measurable. By then, the pair may have traveled hundreds of miles away, pursuing entirely different waters. Few predators possess an influence that continues growing after their departure. Port and Starboard do. Their bodies leave the sea, yet their presence persists through chemistry, memory, and instinct. In a measurable biological sense, they remain woven into the places they have already left, shaping the movements of unseen sharks through signals carried not by sound or sight, but by the enduring language dissolved within the water itself. Wild animals often shape human communities in ways that are easy to overlook until they disappear. A coastline becomes known for a particular migration, a nesting colony, or a seasonal gathering, and over many years people build livelihoods around patterns that seem enduring. Businesses grow, research stations expand, visitors arrive from distant countries, and an entire local identity gradually forms around the expectation that tomorrow will resemble yesterday. Along the southern coast of South Africa, that expectation centered upon one remarkable predator. The small fishing town of Gansbaai, situated on the Western Cape roughly 100 miles east of Cape Town, became internationally recognized because of the waters separating Dyer Island from Geyser Rock. Between those two islands lay a narrow passage known around the world as Shark Alley. Cape fur seals gathered in enormous numbers upon Geyser Rock, creating one of the most dependable hunting grounds ever documented for great white sharks. For decades, visitors traveled there with the expectation of seeing these powerful fish in their natural environment, often at distances measured in only a few feet. From that reputation grew an entire tourism economy. Cage diving operators launched multiple boats each day during productive seasons, carrying photographers, filmmakers, researchers, and travelers eager to observe one of the ocean's most iconic predators. Local employment extended well beyond the boats themselves. Hotels, restaurants, equipment suppliers, transportation services, and countless smaller businesses benefited from the steady arrival of visitors. The great white shark became more than an animal inhabiting nearby waters. It became an important foundation supporting the town's economic life. Research also flourished alongside tourism. Long-term monitoring programs depended partly upon a funding system linked directly to shark diving operations. A portion of each booking contributed toward scientific work, helping support surveys, identification projects, field observations, and the collection of ecological data. Through that partnership, tourism and conservation strengthened one another. Visitors gained unforgettable encounters, while scientists acquired resources necessary to build one of the world's most valuable long-term records of great white shark behavior. Then the pattern changed with astonishing speed. As the influence of Port and Starboard spread through the region, great white sharks abandoned familiar feeding grounds that had remained productive across many years of observation. By the year 2018, Shark Alley no longer offered reliable encounters with the species that had defined its international reputation. Boats could still travel the same routes. Waves continued breaking against the same rocky shores, and seals still occupied their colonies. Yet the animals visitors had crossed oceans to witness were largely absent. The economic consequences followed almost immediately. Operators accustomed to full schedules suddenly faced days without viable great white shark encounters. Some companies adapted by expanding whale-watching excursions or offering broader marine wildlife tours. Those alternatives provided valuable opportunities, yet they did not consistently replace either the volume of visitors or the revenue once generated by shark-focused tourism. An industry that had matured over decades found itself forced into rapid reinvention. The effects extended beyond local businesses. As shark tourism declined, the financial support connected to each booking also diminished. The very monitoring programs that scientists depended upon now faced shrinking resources. At precisely the moment researchers most needed extensive fieldwork to understand the rapidly changing ecosystem, one of the principal funding mechanisms sustaining that work weakened alongside the disappearance of the sharks themselves. An unusual feedback loop emerged. Ecological transformation reduced tourism. Reduced tourism lowered financial support for scientific observation. Less funding made it more difficult to document the ecological transformation already unfolding. Researchers found themselves attempting to understand one of the most significant predator-driven changes ever recorded, while the practical means of studying it steadily eroded beneath them. The consequences reached beyond Gansby alone. Communities surrounding False Bay, including Simonstown, Strand, and villages scattered along the Whale Coast, had developed portions of their wildlife economy around the enduring presence of great white sharks. Infrastructure, research partnerships, tourism, businesses, and public expectations all reflected that assumption. Within fewer than 3 years, the arrival of two remarkable killer whales overturned a regional economic landscape almost as profoundly as it had transformed the ecological one. Conservation often appears straightforward when viewed from a distance. A vulnerable species declines, threats are identified, protective laws are enacted, and recovery becomes the shared objective. Nature, however, rarely arranges its challenges into such orderly patterns. Along the southern coast of Africa, the meeting between great white sharks and killer whales has revealed a situation where every major participant is protected, every process is natural, and yet the outcome remains deeply complicated for those responsible for safeguarding marine ecosystems. Great white sharks have received legal protection in South Africa for many years. They are recognized internationally as a vulnerable species, reflecting widespread concern over declining populations across significant portions of their global range. Deliberately killing, capturing, or harassing these sharks is prohibited under national law, and conservation programs have long sought to better understand their movements, reproduction, and ecological role. Their protection acknowledges that apex predators require healthy populations if marine food webs are to remain balanced. The same legal protection extends to killer whales. As cetaceans inhabiting South African waters, they too are safeguarded from disturbance and deliberate harm. Their presence reflects the health and complexity of the ocean itself, and conservation policy recognizes them as integral components of the natural environment. From a legal perspective, both predator and prey occupy protected status simultaneously. That creates an unusual circumstance. When Port and Starboard hunt great white sharks, no conflict exists within the law because no unlawful act has occurred. Predation between native species remains a natural biological process, regardless of how dramatic its ecological consequences may become. No conservation authority would attempt to prevent wild killer whales from hunting sharks. Such intervention would contradict the fundamental principle of allowing natural ecological relationships to function without human interference. Beyond the philosophical challenge, there is also no practical method capable of preventing free-ranging killer whales from pursuing prey across hundreds of miles of open coastline. The greater concern lies not with the hunting itself, but with the condition of the shark population before the whales arrived. Long before documented encounters between Port and Starboard and great white sharks, human activity had already imposed substantial pressure upon these animals. Along portions of the South African coastline, the KwaZulu-Natal Sharks Board maintained shark control programs using protective nets and drumlines intended to reduce the risk of encounters between sharks and swimmers. Although designed primarily for public safety, these systems caused documented mortality among great white sharks across many decades. Scientific studies examining population trends concluded that this prolonged human-caused mortality gradually weakened the resilience of regional great white populations. Fewer mature individuals remained available to reproduce, recover from losses, and maintain stable numbers through changing environmental conditions. By the time killer whale predation became established within the scientific record, researchers concluded that the population may already have crossed a threshold where absorbing an additional source of mortality became far more difficult than it would have been under healthier conditions. That understanding changes the conservation challenge in important ways. The natural predation carried out by Port and Starboard cannot realistically be managed, nor should it be. The remaining opportunities for conservation, therefore, focus almost entirely upon reducing human-caused mortality wherever possible. Improvements to fishing practices, continued refinement of beach safety strategies, protection of essential habitats, and stronger monitoring programs all represent measures operating over much longer periods than the rapid ecological changes already documented. Recent scientific publications have reflected this difficult balance. During the year 2024, researchers called for enhanced conservation efforts to address continuing declines in great white shark populations. Those recommendations acknowledged that killer whale predation now forms part of the cumulative pressure experienced by the species, while also recognizing that no direct management tool exists for the killer whale component itself. Integrated conservation, therefore, depends upon addressing the pressures created by people, not because natural predation is unimportant, but because it remains the only part of the equation that human society possesses the ability and the responsibility to change. Time has a different rhythm in the ocean. Coastlines appear unchanged from year to year, yet beneath the surface, familiar routes continue carrying the same travelers across immense distances. Some return with remarkable regularity, others vanish for months before emerging again where few expected them. After more than a decade of observation, Port and Starboard remain part of that unfolding movement, still tracing paths through southern African waters that resist every attempt to reduce them to a predictable pattern. As recently as September 2025, the pair was confirmed alive and actively traveling near Calc Bay Harbor within False Bay. The location lay only about 15 miles from the shoreline, where the first scientifically confirmed great white shark carcass bearing their unmistakable feeding signature washed ashore during February 2017. Years had passed between those moments, yet the same coastline continued serving as one chapter within a much longer story, still being written by two aging killer whales. Their range has shown no meaningful sign of shrinking over the course of continuous documentation. Sightings gathered across many seasons indicate movements extending from Namibia to the Eastern Cape, a vast stretch of shoreline encompassing thousands of miles. They do not occupy a single territory, nor do they appear bound to a predictable seasonal circuit. Weeks may pass without a confirmed observation before they reappear hundreds of miles away, continuing a pattern of broad coastal travel that has challenged every effort to anticipate their next destination. Equally remarkable is what has not changed. Despite years of photographic records and repeated encounters, Port and Starboard remain consistently associated only with one another. Researchers have not identified them as permanent members of any recognized pod, nor have they been documented traveling as stable companions of another family group. Temporary encounters with other killer whales undoubtedly occur, as they do throughout the species, yet the enduring picture remains that of two mature males moving together through an immense marine landscape, maintaining a partnership unlike any other documented within the region. The waters they transformed have not remained entirely empty. Great white sharks have gradually reappeared in portions of their former range, particularly around Mossel Bay. Their return, however, has been partial rather than complete. Individuals arrive in reduced numbers, remain for shorter periods, and depart again in patterns that differ noticeably from the stable occupation recorded before the middle of the previous decade. The behavior resembles an ongoing negotiation between valuable feeding opportunities and a persistent source of danger that has never entirely disappeared from the ecosystem. Meanwhile, the story has expanded beyond the original pair. The documented observation of a 5-killer whale group hunting near Mossel Bay during the year 2022 demonstrated that the specialized shark hunting technique had moved beyond Port and Starboard alone. Whether through direct teaching, social learning, or repeated observation, other killer whales within the regional population now appear capable of employing the same remarkable strategy. Exactly how widely that knowledge has spread remains unknown because much of the coastline still receives only intermittent scientific coverage. Age continues to invite careful speculation without offering certainty. Researchers believe the two males are older individuals, yet no confirmed birth records exist, and no reliable method has established their exact ages. Any estimate regarding how many years remain in their lives, therefore, extends beyond available evidence. Science can describe only what observation supports, leaving the future unwritten. One conclusion, however, rests upon direct experience rather than inference. As of September 2025, Port and Starboard remained alive, active, and unmistakably present. Their distinctive dorsal fins, port folding toward the left and starboard toward the right, continue identifying them from remarkable distances. Across countless miles of changing ocean, they move through waters whose ecological history now bears their unmistakable signature, carrying forward a partnership that has altered not only the lives of sharks, but also the way the natural world understands the remarkable possibilities of killer whales. Across the history of life, evolution is often imagined as the great architect of change. Generation after generation, small advantages accumulate until entire species become transformed, their bodies carrying the record of ancient challenges solved over immense spans of time. Oceans have witnessed that gradual process for hundreds of millions of years. Yet every so often, a different kind of change appears, one measured not across geological ages, but within the lifetime of a single animal capable of learning something entirely new. The great white shark occupied one of the most enduring positions in the marine predator hierarchy. For approximately 11 million years, its lineage persisted through changing climates, shifting coastlines, and the disappearance of countless other marine hunters. Entire groups of predators rose, flourished, and vanished, while great white sharks continued occupying much the same ecological role. Their success did not depend upon chance. It rested upon a body refined through natural selection until very few creatures could challenge an adult shark in open water. What Port and Starboard ultimately revealed was not that evolution had failed. Instead, they demonstrated that evolutionary success can sometimes encounter an entirely different force. The shark possessed remarkable speed, powerful jaws, finely tuned senses, and formidable size. None of those traits disappeared. None suddenly became inadequate. Rather, another species acquired access to a weakness that had remained largely unexplored despite millions of years of coexistence. The physical ability had almost certainly existed all along. Killer whales have shared the oceans with great white sharks throughout their evolutionary history. They possess the necessary strength, coordination, and intelligence long before any scientist documented specialized shark hunting. Yet possessing the capability to overpower another predator is fundamentally different from knowing the precise sequence required to accomplish it consistently. Between possibility and reliable success lay a gap that nature itself had left largely uncrossed. Port and Starboard occupied that gap. Whether the crucial insight emerged through independent discovery, gradual experimentation, learning from undocumented whales, or another pathway that has since disappeared from the scientific record remains unknown. What matters is that the knowledge existed. Once a shark could be turned into a state of temporary paralysis, once the location of the liver became part of an established hunting routine, and once those actions were repeated successfully, the relationship between two apex predators changed with remarkable speed. A hunt that might otherwise have depended upon chance became an organized behavioral tradition capable of being repeated again and again. The contrast between those timescales is among the most remarkable aspects of their story. Evolution required millions of years to shape the anatomy of the great white shark. The hunting strategy documented in southern Africa appears to have become established within the lives of two individual killer whales. Nothing about the shark's body had time to change in response. Natural selection operates across generations. Learned behavior can transform ecological relationships almost immediately. For that reason, the events documented along the South African coastline are better understood as a cultural transformation than an evolutionary one. The decisive innovation was not a stronger jaw, a larger body, or a newly evolved organ. It was information retained through memory, refined through experience, and expressed as coordinated behavior. Knowledge became the decisive adaptation. The consequences unfolded faster than evolution could reasonably answer. Great white sharks altered their movements within days. Marine communities shifted across only a few years. Scientific understanding adapted almost as rapidly, while conservation planning struggled to keep pace with changes already underway. Ecological models built upon long-standing assumptions required careful revision because they had not anticipated that two individual animals, carrying nothing more tangible than learned knowledge, could redirect the balance of an ancient food web whose foundations had appeared stable for approximately 11 million years. For many years, the waters of False Bay offered scientists something both uncommon and deeply valuable: continuity. Seasons passed, migrations unfolded, surveys accumulated, and observations settled into patterns that could be measured with growing confidence. Each additional year strengthened the belief that the ecosystem had reached a state of dependable balance. Differences certainly appeared from one season to another, yet they remained within boundaries that ecological monitoring could reasonably anticipate. The long record became more than a collection of observations. It became a trusted baseline against which future change could be understood. That confidence rested upon approximately 15 years of carefully gathered information. Great white sharks returned to familiar hunting grounds. Cape fur seals followed recognizable cycles. Researchers refined population estimates, behavioral patterns, and seasonal movements with increasing precision. Such datasets are exceptionally rare because they require patience extending across many years, consistent funding, and generations of scientific commitment. When they exist, they become the foundation upon which ecological understanding is built. The events that followed did not diminish the value of that record. Instead, they transformed its meaning. At first glance, 15 years of stability appears to demonstrate resilience, suggesting an ecosystem capable of maintaining its structure despite ordinary environmental variation. Port and Starboard revealed another possibility. The apparent stability may not have reflected exceptional resistance to change. It may instead have reflected the absence of any force capable of applying an entirely unfamiliar form of pressure from the highest level of the food web. The system remained stable because one particular influence had not yet entered it. The monitoring program performed exactly as scientific observation is intended to perform. It documented the decline of great white shark sightings, recorded changes in predator behavior, measured shifting ecological relationships, and preserved an exceptionally detailed chronology of transformation. Researchers could identify when patterns began changing and trace many of the consequences that followed. The collapse itself was not hidden. It unfolded within one of the most thoroughly documented marine ecosystems anywhere along the African coastline. What the monitoring program could not accomplish was prediction. Existing ecological models contained many variables, including climate, prey abundance, fishing pressure, seasonal migration, and environmental change. None included the possibility that two highly intelligent predators might introduce a specialized hunting strategy capable of rapidly altering the behavior of another apex predator. Such an event existed outside the assumptions upon which those models had been constructed. That realization has encouraged a broader reconsideration of ecological stability itself. Increasingly, researchers have suggested that marine ecosystems may depend upon conditions more contingent than previously recognized. Long periods of apparent balance do not necessarily indicate permanence. They may instead reflect the current distribution of learned behavior among the animals inhabiting that environment. As long as knowledge remains unchanged, relationships also remain relatively stable. When knowledge changes, ecological relationships may change with remarkable speed. This perspective introduces culture into discussions that once focused almost exclusively upon evolution and environmental conditions. A learned behavior does not require countless generations to spread its influence. It requires only individuals capable of remembering, refining, and expressing that knowledge successfully. Once established, the consequences ripple outward through predators, prey, competitors, and the many species connected across a living food web. The lesson emerging from False Bay therefore reaches beyond the story of two remarkable killer whales. Stability itself may sometimes be less permanent than it appears. An ecosystem can seem unchanged across many years, while remaining vulnerable to a single behavioral innovation that no mathematical model has anticipated. When that innovation arrives, the transformation may unfold far more rapidly than geology, climate, or evolution could reasonably produce. Looking backward, the years once described as stable begin to resemble something subtly different, not a permanent equilibrium, but the interval before new knowledge entered the sea and reshaped everything connected to it. Knowledge is often imagined as a steadily expanding map, with each discovery filling another empty space until the unknown gradually disappears. Marine science rarely unfolds so neatly. Every carefully documented observation has the potential to answer one question while revealing several others that no researcher previously thought to ask. Few modern wildlife stories illustrate that pattern more clearly than the long record surrounding Port and Starboard, where years of meticulous investigation have illuminated extraordinary events while leaving the deepest mysteries remarkably untouched. More than a decade of continuous observation now surrounds these two killer whales. Their movements have been photographed, their hunting behavior has been captured from the air, their ecological influence has been measured through one of the world's most valuable long-term marine datasets, and comparable evidence has emerged from distant oceans. Genetic research, satellite tracking, detailed carcass examinations, and peer-reviewed scientific publications have all contributed pieces to the picture. Yet even with this remarkable accumulation of evidence, several of the most important questions remain exactly where they began. The first concerns their own beginnings. Researchers still cannot identify where Port and Starboard originated before they entered the documented record. Their ancestry remains unplaced within existing genetic databases. No confirmed relatives have been identified, and no earlier observations have established the first years of their lives. Their history appears only when the scientific record finally intersects with their journey, leaving everything before that point concealed beyond available evidence. Equally uncertain is the origin of the remarkable hunting method that transformed their relationship with great white sharks. The behavior may have emerged through individual discovery after an unexpected encounter revealed an overlooked opportunity. It may represent knowledge inherited from whales that were never scientifically documented. Another possibility is that the technique arose through a pathway not yet imagined by researchers. At present, the source of that knowledge remains as elusive as the origin of the whales themselves. The broader distribution of the behavior presents another unresolved chapter. Comparable liver-focused hunting has now been documented in the Gulf of California and among killer whales in Australian waters. Those observations demonstrate that port and starboard are not entirely unique, yet they do not explain how such similarities arose. Independent innovation remains plausible because intelligent animals facing similar challenges sometimes reach similar solutions without direct contact. An equally compelling possibility suggests that specialized shark hunting has existed more widely for far longer than scientists realized, escaping documentation simply because the relevant populations were rarely observed. Available evidence supports both interpretations while conclusively proving neither. Attention also remains focused upon the future of the great white sharks themselves. Scientists continue monitoring whether regional populations will gradually recover, stabilize at reduced abundance, or decline further under the combined influence of natural predation and continuing human-caused pressures. Ecological recovery often unfolds across many years, sometimes decades, making confident prediction impossible while the process remains underway. Beyond those immediate questions lies an even larger uncertainty reaching into the unwritten history of the oceans. Modern scientific monitoring occupies only a tiny fraction of marine history. Before systematic observation, coastlines changed without cameras, research vessels, satellite transmitters, or long-term ecological surveys. It remains entirely possible that similar events unfolded generations or even centuries earlier, reshaping predator communities before anyone possessed the means to record them. It is equally possible that the transformation documented in False Bay represents something genuinely exceptional. The available record cannot distinguish confidently between those possibilities because so much of the ocean's past exists beyond human observation. Perhaps that is the most enduring lesson left by Port and Starboard. The years devoted to studying them have not carried science toward a finished conclusion. Instead, they have revealed how much remains beyond the edge of present understanding. The researchers who know these whales most closely have acknowledged this with remarkable openness. A decade of careful observation has resolved many important mysteries, yet it has also uncovered new foundations of uncertainty, reminding us that discovery is measured not only by the answers we obtain, but also by the questions that endure. Places often outlast the stories told about them. The shape of a coastline remains familiar, while the lives moving through it gradually change until one generation remembers a landscape differently from the next. False Bay carries that quality today. The headlands still frame the same broad curve of water. Cold Atlantic currents continue sweeping around the Cape Peninsula before mingling with warmer influences arriving from the Indian Ocean. Wind crosses the open sea much as it always has, tracing patterns over a surface that appears timeless despite everything that has unfolded beneath it. The islands remain as enduring landmarks within that familiar geography. Seal Island still rises from the bay, while Cape fur seals continue gathering upon Geyser Rock in astonishing abundance. Their colonies fill the air with movement and sound, following rhythms established across countless generations. Yet the ecological setting surrounding those colonies has changed. The presence that once imposed a particular pattern upon their daily lives no longer shapes the bay, with the same consistency. Their world has not become simpler, only different, adjusted to a predator community that now follows another arrangement. Great white sharks have not vanished entirely from these waters. Since the year 2020, researchers have documented periodic returns to portions of the bay, once occupied throughout much of the year. Those appearances differ noticeably from the long residency patterns preserved within earlier records. Fewer sharks arrive together. Their visits tend to be shorter. Individuals move through the region with less permanence, often departing before establishing the prolonged seasonal occupation once considered characteristic of False Bay. Some researchers have proposed an intriguing possibility regarding those returning animals. The sharks appearing today may represent younger individuals with different life experiences than those that abandoned the bay during the earliest encounters with Port and Starboard. Having never experienced the original disruption themselves, they may be exploring habitat that older sharks learned to avoid. This interpretation remains under study, yet it illustrates how memory can shape ecological patterns even when the original event has already passed. The water itself does not preserve every trace indefinitely. Chemical compounds released during predation gradually disperse, break apart, and become incorporated into the ordinary chemistry of the sea. The distinctive signals associated with shark liver oils diminish over time until they no longer communicate immediate danger. In that sense, the ocean does not remember forever through chemistry alone. Living animals remember differently. A shark that survived the evacuation of familiar feeding grounds carries experience within its nervous system rather than within the surrounding water. Learned avoidance may continue influencing movement long after chemical evidence has disappeared. Wherever that individual travels, previous encounters remain part of its behavioral history. Knowledge acquired through survival becomes portable, moving through the ocean inside the animal itself instead of remaining anchored to a particular place. False Bay therefore exists today as neither a lost ecosystem nor an unchanged one. It functions according to a different arrangement of predators, prey, and ecological relationships than those documented during the earliest years of continuous monitoring. Energy still flows through the food web. Marine life continues adapting to changing conditions. The ecosystem remains active, productive, and interconnected, even as its structure reflects a history that unfolded with remarkable speed. Perhaps the most extraordinary aspect of this transformation lies within the scientific record itself. Rarely does ecology preserve such a complete account of change occurring within one location, observed by many of the same researchers using consistent methods across so many consecutive years. The years preceding the transition remain carefully documented. The transition itself occupies the same record with equal precision. Everything that followed continues extending that uninterrupted chronology. Future scientists studying marine ecosystems will find both versions of False Bay preserved together within a single continuous data set, allowing the waters before and after Port and Starboard to exist side by side, connected not only by geography, but also by one of the clearest ecological records ever assembled from the sea. Ecology often measures importance in unexpected ways. The largest population is not always the most influential, and the rarest creature is not necessarily the least significant. Some species shape entire ecosystems far beyond what their numbers might suggest, altering the behavior, distribution, and survival of countless others through their mere presence. Their influence spreads outward like unseen currents, touching animals they never directly encounter. Within ecological science, these organisms are known as keystone species because the wider structure depends upon them far more than their abundance alone would imply. Great white sharks have long occupied that role within many temperate marine ecosystems. Their influence extends beyond the fish and marine mammals they occasionally hunt. Simply existing within a region changes how other animals move, where they feed, how long they remain in particular habitats, and the risks they are willing to accept. The continual possibility of encountering an apex predator becomes part of everyday ecological decision-making. Energy flows through the food web not only because predators consume prey, but because prey constantly responds to the credible possibility of predation. For many years, False Bay reflected that familiar arrangement. Great white sharks occupied the highest position within the local predator hierarchy, and countless ecological relationships developed around their presence. The monitoring record captured those interactions with remarkable consistency, revealing an ecosystem organized around a predator whose influence reached well beyond the moments when it actually hunted. Port and Starboard altered that arrangement in a manner that challenged existing ecological language. Their story does not fit comfortably within familiar categories, describing habitat loss, climate change, invasive species, pollution, or direct human disturbance. Instead, two individual killer whales acquired specialized knowledge that enabled them to remove a regional keystone predator from much of its established range. The resulting ecological changes spread outward through the same interconnected relationships that had previously depended upon the sharks. Traditional ecological frameworks offered no established term for such an event. Scientists have long recognized keystone species, ecosystem engineers, and apex predators. The events documented in southern Africa suggest something subtly different, not a new biological classification, but a distinctive ecological role emerging from learned behavior. In practical terms, Port and Starboard functioned as what might reasonably be described as keystone disruptors, individual animals whose acquired knowledge initiated the removal of another keystone species from a functioning ecosystem, triggering cascading consequences across many levels of the food web. What makes this transformation especially remarkable is the mechanism through which it occurred. No environmental catastrophe devastated the shark population. No expanding human industry directly displaced them from False Bay. No newly evolved predator entered the region carrying anatomical adaptations developed across millions of years of natural selection. Killer whales and great white sharks had shared the oceans throughout an immense span of evolutionary history. The decisive difference was not the appearance of a new species, it was the appearance of new knowledge. That distinction carries profound scientific significance. Evolution changes bodies over countless generations. Learned behavior can change ecological relationships within the lifetime of individuals. Port and Starboard demonstrated that intelligence, memory, and culture may occasionally reshape marine ecosystems more rapidly than biological adaptation can respond. Their influence emerged through information rather than anatomy, through experience rather than genetic change. For that reason, their story occupies an unusual place within the documented history of ocean ecology. It represents neither natural disaster nor direct human impact, but another pathway through which ecosystems can transform. Intelligence acted more rapidly than evolution. Culture spread more quickly than anatomical adaptation. A learned solution to a long-standing ecological challenge reorganized relationships that had persisted across approximately 11 million years. The food web possessed no evolutionary preparation for knowledge arriving at such speed, leaving future ecological research with an enduring reminder that the most powerful forces shaping the natural world are not always written first into the body. Sometimes they are carried within the mind. The sea has never measured time by the lives of individual animals. Coastlines have shifted, currents have wandered, and entire branches of life have appeared and disappeared while the waters surrounding the Western Cape continued their endless circulation. Across millions of years, predators have risen to remarkable dominance before yielding, eventually, to changing climates, evolving competitors, or extinction itself. Those transformations ordinarily unfold across intervals so vast that no single lifetime can witness more than a fleeting moment within them. Port and Starboard introduced something that belongs to a different rhythm altogether. Their story demonstrated that an ecosystem can change not only because bodies evolve, but because minds discover. A learned behavior can emerge within one generation and alter ecological relationships before natural selection has the opportunity to respond. The distinction reaches beyond two remarkable killer whales. It suggests that intelligence itself can become an ecological force operating on a timescale measured in years rather than geological ages. Unlike an anatomical adaptation, knowledge does not necessarily disappear when the individual possessing it dies. Many killer whale populations are recognized as cultural societies, passing hunting traditions across generations through observation, repeated practice, and prolonged association between adults and calves. Scientists have documented these cultural pathways and behaviors as varied as intentional beach hunting, coordinated wave washing to dislodge resting seals, and the careful herding of schooling fish into dense bait balls before feeding. Each tradition persists because younger whales inherit experience rather than rediscovering it independently. Evidence from the Gulf of California suggests that shark liver consumption may now belong within that broader cultural landscape. Researchers have observed calves accompanying experienced adults during hunts, feeding upon the same nutrient-rich organs that distinguish these remarkable predation events. Young whales encountering shark liver at an early age are not merely sampling unfamiliar prey. They are participating in behavior that may carry information extending far beyond the meal itself. Exactly how much knowledge is transmitted, and by what learning processes, remains under active investigation. Yet, the possibility alone carries profound ecological significance. That uncertainty now stands at the center of the broader scientific conversation. Comparable shark hunting behavior has already been documented beyond southern Africa. The question is therefore no longer whether specialized liver extraction can occur elsewhere. It clearly can. Instead, researchers are asking whether separate observations represent isolated innovations arising independently, or whether they reveal the gradual spread of a durable cultural tradition moving through different killer whale populations across the world's oceans. Current evidence encourages careful restraint rather than certainty. The available observations are suggestive without being conclusive. Some populations may have developed similar techniques independently because intelligent predators confronted similar opportunities. Others may be connected through cultural pathways that remain poorly understood. Marine researchers continue gathering observations precisely because the existing record remains too limited to distinguish confidently between those possibilities. The challenge extends beyond interpretation of behavior. False Bay benefited from unusually comprehensive ecological monitoring that had already been established before the transformation occurred. Comparable long-term datasets remain uncommon along many coastlines where killer whales and great white sharks overlap. Without sustained observation extending across many consecutive years, subtle ecological shifts can escape immediate recognition, becoming apparent only after the broader pattern has already emerged. That reality leaves the story unfinished in the most meaningful scientific sense. Future transformations, should they occur, may unfold beyond the reach of equally detailed monitoring, waiting to be reconstructed from scattered observations rather than witnessed as they happen. The remarkable chronology preserved in False Bay may prove exceptional, not because ecological change itself is unique, but because so much of it was observed with such extraordinary continuity. What Port and Starboard ultimately leave behind is not only an altered ecosystem, but an expanded awareness that the next profound transformation may begin. Wherever intelligence and opportunity meet beneath the surface, long before anyone realizes that another chapter has already entered the living history of the sea, far beyond the reach of research vessels on any particular day, beyond the familiar viewpoints overlooking the Cape Peninsula, Port and Starboard continue moving through the sea. Their distinctive dorsal fins remain folded in opposite directions, making them recognizable whenever they briefly surface before disappearing beneath the swells once again. More than a decade after they first entered the scientific record, their exact route remains uncertain. They still travel the immense coastline of South Africa, appearing unexpectedly, vanishing just as easily, carrying with them a form of knowledge whose full history remains hidden from those attempting to understand it. The ocean offers few visible reminders of everything that has unfolded within it. Looking outward from the shore, the water appears much as it always has. Long rolling swells arrive from the South Atlantic. Winds reshape the surface from hour to hour, and distant horizons blur into changing light. Nothing upon that surface announces that one of the most carefully documented ecological transformations in modern marine science occurred beneath it. The sea does not preserve monuments. It continues its endless motion without revealing the histories carried below. Yet history remains present in another way. False Bay now exists, with a different ecological rhythm than the one recorded during the earliest years of continuous observation. The difference cannot always be recognized by casual observation alone. It emerges through years of patient measurements, recurring surveys, carefully cataloged sightings, and comparisons extending across decades. The absence preserved within those records is not merely the disappearance of individual sharks from familiar locations. It is the disappearance of a long-established organizing influence that once shaped how many other animals use the bay. Life has continued adapting around that change. Cape fur seals still gather upon their rocky colonies. Marine birds continue searching the shoreline for food. Smaller predators pursue familiar prey. Great white sharks return from time to time, entering waters their predecessors once occupied more consistently before departing again, according to patterns still being studied. The ecosystem remains alive, productive, and interconnected, yet its relationships have settled into a configuration different from the one scientists first documented. Perhaps the greatest achievement of this remarkable story is that it was observed with such extraordinary care. Rarely does ecological science possess both the years preceding a major transition and the years following it within one uninterrupted record. The same waters, examined through the same long-term commitment, preserved an exceptionally detailed account of change. Those observations revealed that an ecological hierarchy, appearing stable across approximately 11 million years, was sustained not by permanence, but by the existing boundaries of learned behavior among the animals participating within it. Port and Starboard reached beyond those boundaries. They demonstrated that intelligence can occasionally alter relationships more rapidly than evolution, that memory can redirect ecological pathways without requiring anatomical change, and that culture may reshape the living world with a speed previously difficult to imagine. None of those discoveries diminish the power of evolution or the immense timescales through which life has always developed. Instead, they revealed another dimension operating alongside those ancient processes, one carried within experience rather than inherited through genes alone. Their story therefore remains unfinished, not because its ending has been withheld, but because the oceans continue changing while observation continues alongside them. Somewhere beyond the horizon, Port and Starboard are almost certainly still traveling through familiar currents, their movements largely unseen between the moments when science briefly intersects with their path. Great white sharks still enter portions of the coastline, sometimes remaining, sometimes departing. Young killer whales continue learning from older companions. New experiences accumulate beneath the waves, becoming tomorrow's traditions before anyone recognizes their significance. The open water keeps its own counsel. It carries memory through living creatures rather than stone, through behavior rather than monuments, and through generations that inherit more than bodies alone. The sea appears unchanged from above, yet beneath its shifting surface, knowledge continues moving with the animals that possess it, waiting for the next moment when careful observation catches a glimpse of history still unfolding.